to lesson 4.2. Today we're going to be talking about greatest common factor. So before we can talk about what greatest common factor is, we got to kind of recap what a factor is. So factors are numbers multiplied together to make a number. So for example, if you have 3 times 4 equals 12, 3 and 4 are the factors of 12 because they multiply together to give you 12. So that means when we're talking about the greatest common factor, we're talking about the greatest factor that 2 or more numbers share. So basically, we're going to be using what we did last lesson with prime factorization. So we're breaking down a composite number into its prime parts. And then basically we're going to be circling all of the ones they have in common and then multiplying them together to show what is the greatest common factor. So that's the first way to do it with prime factorization. So in this example is with 12 and 16. So we're finding what is the greatest number that they both have in common. So in order to do this, we're going to break it down. Now this is a good strategy to use if you're using big numbers because this one is a little bit easier because you don't have to figure out, what all numbers they multiply together to give you that number. Like if you're talking for like 1,000, then this method probably wouldn't be the best. But this one's would be good for that because you break them down individually. So if you break down 12, you get it into 2 and 6. Then you break down 6 into 2 and 3. So in order to get 12, you do 2 times 2 times 3. Now in 16, you break it down to 4 times 4, and then break down those 4s to 2 times 2. So it's 2 times 2 times 2 times 2. So now I went ahead and looked at the prime factorizations of both numbers. And I circled the numbers that they both have in common. So there's a 2 here, there's a 2 there. There's a 2 here, there's a 2 there. There's no 3s and there's no more 2s over here. So that means that 2 times 2 is our greatest common factor, or you could say 4 is our greatest common factor. Now that's the first way of finding the GCF. Another way that you can find the GCF, this is good if you have small numbers like 4 and 8 or something like that, or 12 and 16. Now what you would have to do for this one is just list all of the numbers that multiply together to give you that number. So like 1 times 12 gives you 12. 2 times 6 gives you 12, and 3 times 4 gives you 12. So that's listing all the factors for 12. Now for 16, you have 1 times 16 gives you 16, 2 times 8 gives you 16, and then 4 times 4 gives you 16. So you look at what's the biggest number they both have in common, and you'll see that it's 4. So the GCF is 4. So listing the factors will probably be something easier, like I said, if you're talking about smaller numbers. And prime factorization would be better if you are talking about bigger numbers. Because sometimes it's not very quick to think of all the numbers that multiply together to give you 1,000 because that's kind of a big number. So we don't want to have to do that. So we have 2 different options for you. So let's go ahead and do some examples. Alright, let's go ahead and look at our first example. Our first example has 8 and 10. So we're kind of trying to figure out what is the biggest number they both have in common. So I'm going to go ahead and do it by prime factorization. So I'm going to break down 8 into 2 and 4. 2 is prime, and then break down 4 into 2 and 2. So we have 2 times 2 times 2. So that gives us 8. Now let's go ahead and break down 10. In order to get 10, you do 2 times 5. Both of those are prime, so you have 2 times 5. So what number or numbers do they have in common? We have a 2 here and a 2 here, and that's all that we have. So our GCF is equal to 2. Alright, let's go ahead and look at number 2. We have 10 and 17. Now, for this one, I'm going to do it the other way so you can see both ways of solving the problem. So this time I'm going to list the factors instead of doing prime factorization. So for 10, I have 1 times 10 is going to give me 10. I have 2 times 5 is going to give me 10. So those are my 4 factors that will give me 10. I'm thinking about 17. You have 1 and 17. Those are the only 2 numbers that multiply together to give you that number because that number is prime. So that means the biggest number they share is 1. So the GCF is equal to 1. Alright, for this one down here, we have 3 numbers, so we're going to go ahead and break those down. I'm going to use prime factorization this time. So to break down 30, I have 6 times 5. 5 is prime. Then I have 2 times 3. So my prime factorization is 2 times 3 times 5. So now let's go ahead and break down 45. We have 9 times 5. 5 is prime. Then we have 3 times 3, which gives you 9. So our prime factorization is 3 times 3 times 5. And now let's go ahead and break down 75. When you break down 75, it's 15 times 5. 5 is prime. And you have 3 times 5. And so you have 3 times 5 times 5. So now let's go ahead and see what numbers they all have in common. So let's see, we don't have a 2 in the other one. We have a 3 here, a 3 here, and a 3 here. So they share 3. And they also share a 5. So that means our GCF is 3 times 5, or you can write it as 15. Alright, now let's go ahead and see how something like this would be used in real life. So in this board problem it says, Mr. Clover wants to make shelves using an 18-foot board and a 36-foot board. What's the longest shelves he can make if he wants to use all of both boards? So we have 2 boards we're using, and they're both different sizes. So we need to go ahead and find the greatest common factor. So what's the biggest number that they both share that will be able to cut up those boards evenly? So I'm going to go ahead and do 18 and 36. I'm going to go ahead and do the prime factorization to solve. So 18, we have 2 times 9, and then we have 3 times 3. So we have 2 times 3 times 3. Now let's break down 36. We have 6 times 6, so that's 2 times 3, 2, 3. So it's 2 times 2 times 3 times 3. So here's our prime factorization of both numbers. So let's see, what do they share? I see a 2, I see a 3, and I see a 3. So it looks like our greatest common factor is 18. So if our GCF is 18, that means basically that if you have an 18-inch board and your greatest common factor is 18, that whole board just gives you one shelf. And 36, if you're going to separate that into 18 feet, then that means you would cut it in half, so you would have 2 boards. So that means we'll have 3 shelves from our boards. Alright, if any of this was confusing, go back and watch it again. Go into your book and look at some examples, and as always, you can bring your questions to me. Now let's go ahead and look at some on your own questions. Alright, you have a few problems to do for me. For numbers 1, 2, and 3, you need to go ahead and break them down to find the greatest common factor. On number 4, I gave you a chart, and it shows bike helmets and listed by style and by how many they have. So they have 36 sport helmets, they have 72 road helmets, and they have 45 mountain helmets. So go ahead and find the greatest number of helmets that can be put on each row in a store. Alright, we'll see what you get tomorrow. Good luck.